There's more than one way to skin a rabbit, and there's more than one way to create a Trojan. In this nugget, I'd like to walk you through the creation, deployment, and verification of a Trojan using the Social Engineering Toolkit. One of the tools is like a Swiss Army knife that we want to be familiar with is the Social Engineering Toolkit, or SET, that's available and included as part of current distributions of Kali Linux. And the SE Toolkit leverages the metasploit framework. It also leverages Meterpreter as part of that for compromising and hacking of systems. Although when you bring it up, it says, hey, this is just for good purposes. Don't use it for anything evil. Unfortunately, it's such a powerful tool, it can be absolutely used for evil by the wrong people. So I'd like to walk you through an example of creating a Trojan that when deployed on the victim machine is going to go ahead and call the attacker. And so that the firewall will allow that communication to happen, we can go ahead and use a well-known port, for example, maybe TCP, port 443, so that the firewall will just think, oh, that's HTTPS. And if it's not doing deep packet analysis to take a look at what's really going on, it may not catch it. So when the victim initializes its session out to the attacker, the replies back from the attacker to the victim are really the control channel for that communication, but the firewall may just see that as normal return traffic coming back to the user. And as far as getting that software, this malware, this Trojan installed on this computer, we have lots of options. We could have a fake application, which doesn't do what it claims to do, but rather installs the malicious software, or we could have a legitimate application that's being used as a wrapper around the malware. And then if the user installs the legitimate application, what actually happens is the malware gets installed and the legitimate application gets installed, and the attacker is one step closer to compromising that system. We could have a user who went to a web page, and when they're visiting or clicking, some warning comes up saying, warning, warning, you've got a virus. Click here to fix it. And when they click there to fix it, it actually installs the payload, the Trojan, on the system. And while that Trojan is being installed, the website can give the appearance of scanning and cleaning and fixing problems on the victim's computer, when in reality it's doing nothing of the sort. It's simply deploying the Trojan. If people are using torrents or they're downloading illegal software, it's very likely a lot of that software has extra payloads as part of it. Also, freeware is something to be concerned with. If it's free, why are they doing it? And of course, we could have a virus or a worm that as part of its work is deploying the Trojan as well. So here's what I propose we do. Let's go ahead and run the Social Engineering Toolkit on our Kali Linux box at .109. And then we'll go ahead and let's make our Windows 10 computer the victim. And again, to deploy the payload, we could wrap it in something else that looks more innocent as a Trojan, or we could trick the user into clicking on it, or we could email it to the user and have the user click on it as an attachment. Or if this user has some shares in place, we could place it on their file system with some creative name like README. And one of the cool things about Windows is that it often hides well-known extensions. For example, a .exe or a .com or a .bat for a batch file. So what we could do is we could rename a file, for example, interesting, I'll put interest.txt .exe. Then in the file system, if Windows is basically hiding that .exe, they'll just see interest.txt. Or we could call it interest.pdf.exe. And it's just yet another method that we could use to entice the user to go ahead and click on something, to go ahead and activate it. So for our demonstration, we'll just create a little share on this Windows 10 machine. We'll copy the payload over after we create it using the Social Engineering Toolkit. Then we'll have the user launch it here on Windows 10, and then we'll control that system over here from the Kali box. So on our Windows 10 machine, I just want to verify that Windows Defender is not running. I'll type in Defender. After clicking on the Windows icon in the bottom left-hand corner, we'll go to Windows Defender Desktop app. And I'm going to go ahead and change these settings by clicking on the settings link here. And let's turn real-time protection off. There we go. And that's just like I can go ahead and have Windows Defender not identify this as malicious and stop it from happening. So we'll go ahead and close the Windows Defender settings. And let's go to File Explorer. And let's go to the C drive. And let's make a new folder called Hack. And let's also share that. We'll right-click on Hack. And from the drop-down, we'll go to Share With. And we'll select Specific People. And then we'll type in Everyone. And then click on Add, and we'll change the permissions to Read and Write, and click on Share. So that'll be a convenient way for us to distribute the payload, this Trojan, to this machine simply by putting it on the file system. And we'll click on Done. Next, let's go over to our Kali Linux box. So here in our Kali Linux box, we'll bring up a command shell We'll make that full screen, and then we'll type in SE Toolkit for the Social Engineering Toolkit, and we'll press Enter to launch it. We'll type in Y to the fact that we do agree, and then we're going to choose option number 1 for the social engineering attacks and press Enter. And for the attack I'd like to demonstrate in creating a Trojan, let's go ahead and use the PowerShell attack vectors, which is option number 9. So we'll supply option number 9 and press Enter, and then we'll choose option number 1, the PowerShell alphanumeric shellcode injector. And after typing in 1, we'll press Enter. Now it's asking us for the IP address of the host that we want the victims to go ahead and connect to. And the IP of the host is going to be our Kali Linux box, and that is 192.168.1.109. And then we'll press Enter. And we're going to use port 443 for the reverse. So the client is going to connect to us on port 443. And if they have to go through a firewall, the firewall will simply think that it's an outbound connection request going to an HTTPS server, and it should allow it. So we'll go ahead and specify 443 and press Enter. And we'll say yes to the fact that we want to start the listener service now. And that'll take a few moments to launch the metasploit framework and the additional backend pieces needed for this attack to be successful. Also, if we scroll up a little bit in this output, I love the game Missile Command. It was one of my favorites back in the day. So as we continue to scroll up, here it tells us that if we want the PowerShell commands and attack, they are exported to this location in the file system under root.set reports PowerShell. So we can just go to our local file system to that location, grab those commands, rename it to a .bat file, and simply place that over on the victim's machine in that shared folder that we set up just a few minutes ago. So let's go ahead and unmaximize this and put it over here just for a moment. And over here on the left, we'll open up our file option. So I don't see .set here in the root folder. So what we're going to do is going to click here for options, and then we'll go ahead and select show hidden files. And then if we scroll down, now we have our .set. So if we go into the .set folder, and we go into the reports folder, and we go into the PowerShell folder, here's the actual text file that was generated courtesy of the Social Engineering Toolkit. So let's rename this. Let's right click, and we'll say rename, and let's go ahead and call it 86 PowerShell injection.bat. In fact, let's just call it fun.bat. F-U-N, and click on rename. That looks like a much more attractive file. In fact, let's rename it once more. We'll right click, say rename, and let's call it fun.txt.bat, and we'll click on rename. So if we're on a file system that's hiding well-known extensions, the user may just see fun.txt. So let's go ahead and grab this fun.text.bat file. We'll right click, select copy, and let's go drop it into the shared folder on the Windows 10 computer. So here, let's go to other locations. We'll select the CEH Win10. We'll double click on it. It's going to ask us to authenticate. If we've compromised that system, we know what the password is for Bob. We'll put in the password and click on connect. So here's the hack folder that we shared. We'll go to that folder. We'll right click and paste. And now that fun.text.bat file is sitting on the Windows 10 computer. Also, back here in the Social Engineering Toolkit, if we scroll all the way to the bottom, this system is sitting here waiting for victims to have that Trojan run and then connect back to this Kali Linux box. So here at Windows 10, we'll go into the hack folder. There's our fun.txt. It's really a batch file, but it's hiding the .bat for us. So let's go ahead and double click on it to launch it. Now, a command prompt came up. It did some stuff and it went away. And it doesn't look like there's anything really running on this system. But yet, that process is still running in the background on this Windows 10 computer. And now we can go back over to the Kali Linux box as the attacker, having compromised this Windows 10 computer. So at the Kali Linux box, we've got a connection coming into us from this device right here, .210. And if we type in sessions, it'll show us our existing sessions. We can also do a show sessions. That'll also give us that same information. And if we have multiple victims who have connected to us, we can specify the session we want to be interactive with the command sessions -I for interactive, and then the session ID, which is this guy right there, which is 1. So we'll put a 1 in, press enter, and now we're using Meterpreter to interact with that system. So if we don't know all the commands, we can type in help, and that will give us the options that are available to us. If we scroll to the top of the help output here, there's lots of commands that we could issue. We have core commands, we have file system commands, we have networking commands. So if you wanted to look at the ARP cache, the address resolution protocol cache that's sitting on that Windows 10 computer, we could display it just by issuing the command ARP to see that cache, as well as lots of other network related information. As we continue to scroll down, We have get sid and other commands that can be used to determine the information regarding the user who's currently logged on to that system. We have sysinfo. If we scroll down further, we can start a keyboard logger, and then we can do a key scan dump to actually see what the user typed. There's a set of commands for webcam. There's a command to dump the SAM database, as well as commands to open up a shell directly with that system. So for example, if we did a key scan _ start and pressed enter, we're now doing keystroke logging on that system. So on that Windows 10 computer, if that user goes out to www.paypal.com and logs in as Bob and puts in his password, and I'm just putting in our lab password, and I'm not going to press login because we're not really going to try to log into that site. But the key here is that, pun intended, we've just captured all those keystrokes. So if we go back over to our Kali Linux box and we type in keyscan _ dump and press enter, it's going to show us exactly what was typed in. So I typed in www.pay, and then I did an autocomplete for the rest of that. Then I supplied the username of Bob and the password of nugget !23, which are now captured by the attacker. If we wanted a command shell with that system, we could type in the command shell, and we're in the hack folder. We could go up to the root using our typical DOS navigation commands. It also supports many of the Linux navigation commands. So we do a dir here, and cd users, dir, cd bob, dir. So effectively, we have access to the file system on that compromised computer. In this nugget, we've demonstrated how we can create, launch, and verify a Trojan using the Social Engineering Toolkit. I hope this has been informative for you, and I'd like to thank you for viewing.